Next week, Tuesday, is your test on 5.1, 5.2. You have 6, or you will have 6 things by then that are extra practice for that. There's a pink sheet, front and back. There's a green sheet, and there's a book assignment from 5.1. There's a book assignment and 2 goldenrod sheets from 5.2. You haven't gotten the 2 goldenrod sheets yet from 5.2. We'll give them to you either tomorrow or Friday. Okay? So there's 6 things that you can be doing in preparation for that test on Tuesday. Mrs. Hill and I talked yesterday, we're going to do the 80% rule for that stuff. So if you're in that 80% or below category for those 6, okay? If you're below it, you have to do the 6. If you're above it, they're optional. Okay? Good? All right. So let's dive headfirst into the law of sines. We're going to spend today on the regular law of sines. Tomorrow we're going to do the ambiguous case of the law of sines. Friday we'll wrap everything up, law of sines. Okay? So when you were in geometry, you found that the area of the triangle was half the product of the base times the height. And 1/2 BH is the area of any triangle. Okay? So when it's a right triangle, it's nice, because it's just 1/2 leg times leg. Okay? All right? But not every triangle is a right triangle. That's the downfall with life. Not every triangle is a right triangle. So if I were to look here at angle C, if I lock in angle C, and I look particularly at that triangle, because now I've got a right angle, I've got a right triangle, I can say with great certainty that the sine of angle C is the height of that triangle over side B. Right? And then I can say with great certainty that B times the sine of angle C is equal to the height. So that when it comes to 1/2 of the product of the base and the height, the half of the product, so that's 1/2, the base, what's the base of the big triangle now? Side A, right? So now if I'm looking at the big triangle, the base is A, and the height is B times the sine of C.
Why is that B?
The height is not B, the height is B times the sine of C. We just found that over here on the left side. Okay? Right? Then I went to the big triangle for the right side. Right? But what if I don't like angle C? If I don't like angle C, well, then we can go to angle B. Right? Same process, except now the height is going to be side C times the sine of angle B. The base is still A. 1/2 is still 1/2. Right? So we'd get that one. But what if we don't like angle B? What's my other choice? Go to angle A. Now my height's going to change if I go to angle A, but the process is going to be the same, and so I get that. Right? Okay? So, those 3 all represent the area of the same triangle. So what do I know about those 3? They're what? They're equal. So all 3 of those are equal to each other. Okay? They're all the same triangle. They all represent the area of the same triangle. We didn't change the shape of the triangle at all. So all 3 of those are equal to each other. Boom! They're all equal. Right? let's do some math on that three-part equation. Okay? First off, we found out yesterday that we're not big fans of fractions, right? Okay, so how can I get rid of the fraction? Multiply everything by 2. Okay, so first off, let's multiply by 2. If I multiply by 2, I'm left with AB sine of C equals AC sine of B equals BC sine of A. Right? Now, what I'm going to do is I am going to divide oops, I put it in capital letters. I didn't want to put it in capital letters. By ABC. So I'm going to divide this by ABC, divide this by ABC, and divide this by ABC. Simplifying now, A cancels out an A because they're all being multiplied. B cancels out a B because they're all being multiplied. So that leaves me with the sine of angle C divided by side C A cancels out A, C cancels out C, leaves me with the sine of angle B divided by side B. B cancels out B, C cancels out C, leaves me with the sine of angle A over side A. And we call that the law of sines. Okay? And the law of sines says that the sine of an angle is proportional to the side lengths in any triangle. So this works on any triangle. SOHCAHTOA only works in right triangles. Law of sines works for any triangle. Okay? However, a little side note for you is that you have to have one complete fraction in order to use the law of sines. Put more stars on top than I did on the bottom. Okay? You have to have an angle and its opposite side in order to use the law of sines. Okay? Have to. Otherwise you can't do it. Okay? So, on the back side of that law of sines worksheet is some examples. Okay? So, let's go into doing them. Before we start number 1 here, I would like to ask the question of what does it mean when I ask solve the triangle? Yep.
It would mean to solve for all of the different angles and sides that you don't have yet.
Okay, so how many sides and angles will I be given?
Well, you would get at least one side and one angle.
We'll always give you 3 bits of information. So one side, one angle for sure, and then either another angle or another side. Okay? So you'll always be given 3 things, which means you have to find how many things? Lukey?
2.
Give me another chance. 3. Okay? So, because there's 6, because there's 3 angles and 3 sides, if I give you 3 of them, that means you got to find 3 of them. That's what solving a triangle means. You got to find the 3 missing parts. Okay? Alright? Alright, so now we know what that means. So, my next question to you is, does it matter which one's angle A and which one's angle C in this particular problem? Does it matter? No. So if you wanted to put angle A down here, so I got to go back to my regular pen. If you wanted to put angle A down here and angle C over there, that's fine. If you wanted to put angle A at the top and angle C on the left, that's fine. Doesn't matter where you go, okay? So, but angle A is locked in at 48 degrees. Angle C is locked in at 62 degrees. Okay? Side A. Which one, left, right, bottom, is side A? Agree with the right. Remember, sides are opposite their corresponding angle. So if it's angle A and side A, we have to be opposite them. Okay? That means we need to find angle B, side C, and side B. Those are the 3 things that we have to find. Okay? Which one do you want to find first? You be the picker, I'll be the grinner.
Angle B.
Angle B? How are you going to go about finding angle B?
180 minus the other angles.
Okay.
And just make it positive.
Well, won't it always be positive though?
Yeah.
Yeah. Okay. If you do 180 minus 48 minus 62, okay, because the 3 angles have to add up to be 180 degrees, you should always be positive. And so I get here that angle B is what? 70? Check it again. 180 minus 48 minus 62. 70. Okay. Had me scared there for a minute. Okay. So this is 70 degrees. Okay. Do I have a complete fraction for my law of sines? Meaning, do I have an angle and its opposite side? Yeah. Okay, I do. So I'm going to use that as, I call it, my control. That's what I'm going to start with. So the sine of 48 degrees over 16 is going to equal, let's just go in alphabetical order, the sine of 70 degrees over side B. And the sine of 48 degrees over 16 is going to equal the sine of 62 degrees over side C. Okay? How am I going to solve those? We got one? Not common factors, or common denominators, what you think. That's if we were adding or subtracting them. We can cross multiply. We got 2 equal fractions, so this is where we can do that cross multiplication stuff. Okay? So, B times the sine of 48 degrees is going to equal 16 times the sine of 70 degrees. Okay. And then B here would equal 16 sine of 70 degrees all over the sine of 48 degrees. Okay. Now, the reason why I said you should use your calculator and use that calculator all the way through is because each calculator is just a little different in how you type it in. Okay? So if I go to type this in onto my calculator, I am going to go 16 times the sine of 70, but mine's in radians, so I've got to put mine into degrees. Okay? Yours might be in degrees, you might not have to do that step. And that's going to be divided by the sine of 48 degrees. And that's going to equal 20.2317. Oops, that didn't go.
What do you want us to round this to?
We'll talk about that in a minute. Okay. With me? The math for side C is going to be the same. What's the only thing that's going to change? Yeah? Instead of sine of 70, right? So here, this side C is going to equal, if I follow along with this math, 16 times the sine now of 62 degrees divided by the sine of 48 degrees. Okay? Which is nice if you're using a graphing calculator, because then you can just go like this. Oops, maybe not. You can go like this, and then just change this to 62. And get 19.01. So, Tasha asked the question before, what do we want to round to? I would say that 2 decimal points would be okay. Are you okay with 2 decimal points? A little more accurate than 1. Okay? What I would like you to do now is I would like you to do number 2. So, angle B is 24 degrees 10 minutes. Angle C is 61 degrees 20 minutes. Side B is 4. So that means we have to find angle A, side A, and side C.
If you did turn it into degrees, would it be 10 divided by 60 or 100?
10 divided by 60, yes. And then that gives you a decimal point, but 10 divided by 60 is 1.6 repeating. If you round it to 1.7, now you're going to be off because you're rounding at the start and then you're using it as we go. You know what I mean?
Yeah.
So whereas if you just let it be, you know, on all calculators you can do degrees in minutes and seconds. Okay? So angle A here then is going to be 180 degrees minus 24 degrees 10 minutes. OCD kicking in. Minus 61 degrees 20 minutes. So I get angle A here as 94 degrees 30 minutes. Yes?
Can you show us how to do the minutes on that calculator?
Which calculator? That one? It is that. Here, hold on one second. Let me pause this video. Everybody good on that now? Okay. What's up?
Okay, I think I figured it out, but I didn't get the answer that you had.
Did you get 94.5? You might have typed something in wrong there.
It didn't happen.
Give me a second. So then, if I'm solving for, let's go in alphabetical order then. So the sine of 24 degrees 10 minutes divided by 4 is going to equal the sine of 94 degrees 30 minutes divided by side A. That's one of them. And then the other one is the sine of 24 degrees 10 minutes divided by 4 equals the sine of 61 degrees 20 minutes divided by side C. Okay? Which part didn't work for you, the 94 degrees or the finding the side lengths? Okay, I'm not there yet then.
No. No,
The
the 94 degrees.
What?
The 94 degrees. That's what didn't work. It gave me 1.65.
Because you're in radians.
But I typed in degrees. I put degrees after every number.
That gave you a radian then. Sometimes they're tricky like that.
Well, what am I supposed to do to not?
Convert it to degrees. Times 180 divided by pi. So I get A here as 4 times the sine of 94 degrees 30 minutes divided by the sine of 24 degrees 10 minutes. Go to the calculator. 4 sine of 94 degrees 30 minutes divided by the sine of 24 degrees 10 minutes, and that gives me 9.74046. Okay. Angle C, or not angle C, excuse me, side C, we can shortcut it. That's going to be equal to 4 times the sine of 61 degrees 20 minutes divided by the sine of 24 degrees 10 minutes, and that's going to give me side C here as 8.57295. Logically speaking, which angle, based off of this triangle, which angle, or I shouldn't say, well, which angle is the largest? What's the biggest angle? Angle A, right? Which side's the longest side? Should be what? It should be A. Okay, because biggest angle produces biggest side. Which angle is the smallest? B. Which side length is smallest? B. Okay. Smallest angles produce smallest sides. Okay. So angle A here was 94 degrees 30 minutes. Side A was 9.74. Side C was 8.57. Agree? Okay. All right, so when we go to apply this stuff into the real world, best spot to do it is navigation. Now, navigation is different than trig because of two things. What are the two things, remembering back to navigation? Navigation, remember, is north, south, west, east. What's the two big things with navigation? 0 is where? 0 is up north. Okay? What's the other big thing in terms of angles? Yeah, it's all bearing and navigation and north something west and all that fun stuff. But what's the other big thing? It goes clockwise instead of going counterclockwise. So that this then would be 90, this then would be 180, and this then would be 270. Okay? With me? All right. Now, we're on the second sheet now on the law of sines sheet. Or law of sines side. It's hard to say. Law of sines side. Okay? Because there's a law of cosine side, which you'll need for next week. We're on law of sines side. Okay? So the first problem is, a plane flies 500 kilometers with a bearing of north 44 degrees west from B to C in the picture below. The plane then flies 720 kms from C to A, and A is due west of B. Find the bearing of the flight from C to A is the question. Okay? Well, if I am flying 500 miles at a bearing of north 44 degrees west, that's going to be my 44 degree angle in there. Now, if I know that A and B are due west and east of each other, then I also know that this angle in here is 46 degrees. If A is not due west of B, I can't say that. But because it said that A is due west of B in the last sentence, I can say that. Okay? So the plane takes off from B, flies to C. Then it makes a turn, and it flies to A. And that flight is 720 kilometers long. Okay? It is asking for the bearing of the flight from C to A. So if I expand on C here, I need this angle in there at C. Based off of my triangle, what's the only angle that I can find? What's the only angle that I truly can find?
You could find angle A.
I can find angle A using the law of sines, right? All right, let's do that. Let's find angle A using the law of sines. So the sine of angle A divided by 500 is the sine of 46 degrees divided by 720. Just went too far. Doing some cross multiplication, 720 times the sine of angle A is going to equal 500 times the sine of 46 degrees. I need to get A by itself, so the sine of angle A is going to be 500 times the sine of 46 degrees divided by 720. I need to find angle A, so what do I have to use? Inverse sine. So angle A here is going to equal the inverse sine of all of this. Okay? So depending on how my calculator is set up, mine is currently set up in radians, but I can still do this even with it set up in radians. So if I type, oops, I missed the 500 part. So if I type the 500 times the sine of 46 degrees divided by 720, if I do that, I get my answer, but that's in radians. So remembering back how to convert radians, I multiply by 180 and divide by pi. And so I get 29.9697 degrees.
You said it was alright to just call it after 2 decimal points?
Sure. I just always put down whatever it is, and then round later. Okay? Alright? So that's this angle right here. 29, I almost put 27, 29.97 degrees. Right? Now, if I do some funky math, which really isn't that funky, but if I were to drop that down there and make this a right triangle, did I find my angle that I need? What is it? .03 degrees up in there, right? Okay. Now the question that it's asking is, what is the bearing of the flight from C to A? Well, that would be, so that angle is 60.03, but the bearing is 240.03 degrees. Because 0 starts up on top, and I've got to go all the way around 90, 180, and then 60.303 more. So that gives me a bearing of 240.03 degrees. Or, because this one was in that north 44 degrees west kind of a thing, this one could also be south because we're heading in a southerly direction. We're going down south 60.03 degrees west. Either one of those two, then, is my answer. Okay? Try number 2. So a boat is sailing due east parallel to the shoreline at 10 miles an hour. At a given time, the bearing to the lighthouse on the shoreline is south 70 degrees east. So I should have also put this one over here. And then I think I can paste a new one. Look at that. Oh, tap the brakes. There we go. Put 2 of them in there. Okay. So south 70 degrees east gives me an angle here of 70 degrees. Which means that the angle A in my triangle is 20 degrees. Then 15 minutes later, the bearing to the lighthouse is south 63 degrees east. So that means that this angle in here is 63 degrees, which means angle B of my triangle is 153 degrees. Because there's 90 plus 63 is 153 degrees. If you've got a triangle where one angle is 153 degrees and the other angle is 20 degrees, 180 minus 153 is 27, minus 20 leaves me with a 7-degree angle down there. Okay? We need to solve for either side B or side A. Doesn't matter which one we solve for, it's not the answer. There's another step beyond that. Okay? So I'm going to just set up one of those. Okay? Actually, I'll set them both up. Why not? Doesn't hurt. So the sine of... Oh, wait, tap the brakes. I can't set them up yet because I don't have a complete fraction yet, do I? The boat is traveling at 15 minutes at 10 miles per hour. Well, what part of an hour is 15 minutes? It's a quarter, right? So this is 1/4 times 10 miles per hour tells me that the boat traveled 2.5 miles. That's a fast-moving sailboat. Okay? So this is 2.5. Now I can use the law of sines. So the sine of 7 degrees over 2.5 is going to equal the sine of 153 degrees over B is going to equal the sine of 20 degrees over A. Okay? If you do that math, you should get side A as 7.01612, or you would get side B as 9.31306. Either way. Okay? But the question is asking, how far is the boat from the shoreline? So if I go back up here to my diagram, the boat from the shoreline is, well, what color haven't I used yet? We'll go with that one. Is this side length right there, if I use side B. Or it's that side length right there if I use side A. So I've got one extra step here that I need to do. So my first triangle might look like this, where this is 70 degrees. That's a right angle. I need to solve for that side. And this side is 9.31306. Or it might look like this, where this angle here is 27 degrees. This side is 7.01612, and I need to solve for that one. Okay. In either case, you should get the distance here as 3.185 miles. Up here it would be a cosine. So this would be x is going to equal 9.313 cosine of 70. Down here it would be sine. X is going to equal 7.016 sine of 27. Barely fit it in there. Okay? With me? Now, I will tell you this, that this afternoon I will be recording some more examples of these, and I will be putting them on It's Learning this afternoon. So if you're still a little confused with law of sine ones, I'll do a couple more. They're going to come right off of your two worksheets. They're examples 3 on both of those worksheets are the ones that I'm going to put on there. Okay? Have yourselves a great, grand, and wonderful day.